Alright, so this is a little bit tougher problem. You can always tell the little tougher problems are going to be usually with a little Exeter in parentheses from the Exeter curriculum. But this problem is definitely doable, so let's take a look at it. So we have a rectangular field. Okay, so Fran is going to be walking around this rectangular field. Hopefully your rectangle looks nicer than mine, but with the tablet it's a little bit hard. So let's see. So Fran's going to take a shortcut along the diagonal, thus saving a distance equal to half the length of the shorter side. Find the length of the long side of the field, given that the length of the short side is 156 meters. Now, for me, word problems get a little bit confusing because there's so much going on, so I've got to break it down one small piece at a time. And I think that's the toughest thing about word problems, because the math here isn't going to be super challenging. It's really just going to be your ability to pick out the important information and organize it. So let's take a look. So remember, it's a rectangle, so I'm going to put a little right angle symbol here, there. And it says to find, so she's going to be walking along the diagonal of this rectangle. If she didn't walk along the diagonal, it says that the short side is going to be 156 meters. So I'm just going to write 156 on the side. And the long side is going to be unknown, so I'm just going to call it x. Now we've got to go back to the idea here of the diagonal. What does it actually mean when she's going across the diagonal? So it says that she's taking the shortcut along the diagonal, thus saving a distance equal to half the length of the shorter side. So really you've got to think about, if she's saving distance, what is she saving from? And that's a good question. So she's really saving the distance of walking along the outside of the rectangular perimeter there for half of it. So if she were to do that, her distance would actually be x plus 156. That's how far she would travel if she went across the outside. But for the diagonal, she's going to be doing that, but it says that's the distance, and then it says she's going to save a length, or a distance equal to half the length of the shorter side. So the shorter side was this 156 over here. So she's going to save half of that. So I'm going to write in minus, because that's saving, you're cutting out 1/2 of 156. Okay. Now I'm going to put an arrow here just so we have an idea of what I'm actually writing about here. But this looks a little jumbled here, so I'm just going to go ahead and simplify it. So this is just going to be x plus, and then 156 minus half 56 is just going to be 78. So I'll have x plus 78, and that's going to be the length of the diagonal. Now, you've got to think about not only how to do this problem, but why would I assign this problem? And really this goes back to the main theme of this this class, which is going to be on using Pythagorean theorem and recognizing where it shows up. So in this case, we have a rectangle which has right angles, so we have a right triangle we can deal with here. So if I'm looking at this thing here, I have the base being x, the height being 156, and now I have the length of the hypotenuse, which is x plus 78. So really, I'm just going to go ahead and set that up using Pythagorean theorem. So I have x squared plus 156 squared equals to, and I'll put parentheses, x plus 78 squared. Notice, remember, it's the quantity of x plus 78 that's squared, not x plus 78 squared, okay, where just the 78 is being squared. All right, now for this thing, feel free to use your calculator. I went ahead and did the calculations before I started writing this out just to save some time, but when I start to simplify this, I have x squared plus, and 156 squared comes out to be 24,336. And then the x plus 78, that quantity squared, remember, you got to go through and either do a FOIL method or a box method. It's really just the distribution property, but you end up with x squared plus 156x plus, and then 78 squared is 6,084. Okay, but what's really nice about this is look on both sides of what's common. And you should notice that there's an x squared on both sides. So if I subtracted x squared from both sides, I don't even have to deal with a quadratic equation at this point anymore. So, but what I can do also here, I'm just going to combine two steps, is I'm going to move the constant of the 6,084 to the other side. Okay, and when I do that, I end up with this 18,252 equals to 156x. Okay, and I'm just solving for x here, so I'm just going to divide both sides by 156. Okay, and like I said, I already worked this out, so I'm just saving me some time here. I will end up with x equals 117, and that was meters. Okay, so we actually are able to do this problem. It's not too bad. It's really just the word problem side of it that's going to throw people off. So take your time, break it down. Now that I went through it, try to put this aside and try to work it out on your own. All right, good luck.